Alright, so we should be on 5.6 today. Yesterday we talked about finding the what? Remember we used the pegboards, and what did we find? This slope. We found the slope. What was the ratio of slope? What over what?
Height over base.
Height over base. We also called it rise over run. Okay? And so we're still going to be talking about that. If you look, okay, it says it right here. Slope is the value of the ratio of rise of a line to run of the line between any 2 points. We also talked about, and I would make note of this, that slope is the height over the base or it is rise over run. Or what axis, when we were graphing and stuff, what axis is the height? The y-axis. And what axis is the base? The x-axis. So all of these things here are the slope. Okay? Today we're going to talk about something called the constant of proportionality. You say that? Constant of proportionality. That's what we're talking about today. And it gives us the definition up here. Okay? Two quantities, x and y, are proportional when y equals kx, where k is a number and k cannot equal 0. The number k represents the multiplicative relationship between the quantities and is called the constant of proportionality. That's a big, huge, jumbled mess. Does anybody understand what that says? No. It's lots of big, fluffy words. Okay? Basically, what it's saying is that the constant of proportionality is k. Okay, we're giving it the variable k. And what k is equal to? K is equal to y over x. The ratio of y to x. What else is equal to y over x? The slope. So the constant of proportionality is also the same thing as the slope. You can also rewrite this, like let's say I wanted to solve for y. What would I have to do if I wanted to solve for y? The x using what operation? Well, what operation is currently happening? Y is over x. What operation is that? So the opposite would be, so if I wanted to move the x over, it would be y equals k x. These equal the same thing. Okay? So to find the constant of proportionality, we're taking the y and putting it over the x. I want you to basically understand that k also equals slope. It's all the same thing. They're just different words. Okay? But there's a kicker here. It's only k and it's only proportional if it passes through the origin. That's the most important part. We know it's proportional if it goes through the origin. We know x and y are proportional if it passes through the origin. Look here at this graph. Where's the origin at? In the middle where the x and y cross over. What is that location? Okay, that's my origin. So as a reminder, the origin is at 0, 0, right? if my line is going to pass through 0, 0, then it is proportional. So the line has to go through the origin in order for it to be proportional. Okay? When we talked about slope yesterday, what did we say slope was also equal to? Value or unit rate. The value and the unit rate gave me my slope. This is only true if it passes through the origin. Okay? Very important to look at the origin. This is actually really, really easy because if you just look at it, and if the line goes through the origin, it's a yes. If the line doesn't go through the origin, it's a no. Okay? So let's look at some of these examples. It says, tell whether x and y are proportional. Explain your reasoning. So you just did an IXL over testing these points to see if they're proportional. You just did cross multiplication, right? 1 times 0 is 0, and negative 2 times 2 is negative 4. Is this going to be proportional? No. So that's one way to test for proportionality. Another way is to graph these points. Okay? Do you see this is x and this is y? Okay? So if I were to graph these points, I'm going to erase this so I can see a little bit better. I'm going to go over 1 down to negative 2. I'm going to go over 2 but up 0. Over 3 up 2. And over 4 up to 4. If I were to graph this line, which was not very straight with me, does that go through the origin? So is this a proportional relationship? So this is not proportional. Okay? Let me give y'all. So it's going to start getting dicey here in a second. Dicey. If it's going to be. If you can't draw, not. I mean, it could be spicy. Graphing can be spicy. You know. Fun and thrilling and spicy. I can't draw a straight line to save my life. That's why I'm not an artist. That's why I'm not a hairstylist, because I would never be able to cut people's hair straight. They'd walk out of my room with not good hair. I would mess up your tape line, yes. Yes, absolutely. I'll give y'all one. Alright. So, we decided not proportional. And we can check it with the tables by doing cross multiplication. Okay? Or cross products.
Wait, so we don't have to do the graphing thing?
Well, sometimes they're only going to give you a graph. So we're going to do the graph so that you can see on a graph if it's proportional or not. Alright, so if we look at example B, where are we starting? What's our points? X is 0, y is 0. So I'm going to go, where is 0, 0? The middle, the origin. Okay? And then I'm going to go 2, 2. So I'm going to go over 2, up 2, over 4, up 4, over 6, up 6. And then I want you to take your ruler. Oh, it's not going to let me do it. Yeah, it's not going to let me do it. Ah! Y'all can't get my ruler off the screen. I know. It didn't work. I know. Alright. Let's try this again. I'm going to use my little line tool here. Alright. Is this proportional?
Yeah.
How do we know it's proportional?
Because it goes through the origin.
Yes, because it goes through. What would be the slope or the constant of proportionality here? How would I find the constant of proportionality?
Well, wouldn't it be doing
Alright, let's look. It's the slope. How did we find the slope yesterday?
We counted each basis in between it and then.
Uh-huh, we counted
did the
spaces.
base, we did the height first and then the base.
So if you look here, if I go from this point to the second point, and I connect the dots and make my little triangle right there. What's the height of that triangle? 2. What's the base of that triangle? So if I do 2 over 2, I get 1. Let's see if it's the case for, oh, I didn't plot my points right. Why are you gonna tell me I didn't plot my points right? Well, thank you. That. There we go. That makes more sense. Okay. Sorry about that, y'all. Alright. If I go from the second point to the third point and I make that triangle, what's the height to base? 2 to 2, which is the same as the first one, right? And then if I do the height to base again, it's 2 to 2. So what is my slope or my constant proportionality? 1. My K equals 1 to 1 or just 1. Okay? Alright, we good so far? Alright, let's turn our page. Same thing. I want you to graph your points. Graph your points. Draw your line through the points and test to see if it's proportional or not. Alright, is it proportional or not proportional?
It's not proportional.
How do we know it's not proportional? It doesn't go through the origin. So this is a big not, because, y'all know that was the shorthand for because, B/C means because. It doesn't pass through 0, 0, or the origin. You could also test it with the table. 1 times -2 is -2, and 0 times 1 is Is that proportional? No. Okay? Y'all try number 2. Y'all do 2 and 3. Alright, so number 2, I go over 1, up 4, over 2, up 8, over 3, 12, and then over 4. Doesn't quite go all the way up. I take my line, will it pass through the origin? Yes. What if I can't tell? What if it's hard and I can't tell? What can I do to test to see if it's proportional or not? I can use cross multiply over here with my x and y's, right? 1 times 8 is 8, and 2 times 4 is, and I can test these. 4 times 12 is 48, and 16 times 3. Is this a proportional relationship? Yes. What is the slope or the constant of proportionality, the k? What is the slope of this? How can I find the slope? Jeremy? We make the triangle like Adam said and count the spaces in between. So go from one point to the next. So from here to here. What's the height of that triangle? 4. 1, 2, 3, 4. What's the base of that triangle? 1. We could test to see if the other one's the same way. What's the height of that triangle? 4. 1, 2, 3, 4. And the base is 1. So if I do height to base, or if I call it y over x, what is my slope or my k here? 4 over, what's my base? 1, which equals just 4. So what this is saying, every time I go up 4 spaces, I have to go over how many? 1 space. Up 4 spaces, over 1 space. Up 4 spaces, over 1 space. Alright, what about this one when you graphed it? Did anybody get to graphing this one?
I did.
Okay, so when I come over, -2, up 4, 1, 2, 3, 4, and then -1, up 2, oh, 0, 0, I go to the origin, and then I go 1, 2. What do y'all think about this one? Is this proportional? Some are saying yes, and some are saying no.
No, because this is, when I put 0 at the back, 0 in the calculator, it said, don't pick the not 0 or. I mean,
Alright, by definition, it has to pass through the origin. Is it going through the origin?
no, ma'am.
Is this making a straight line?
No,
No, it makes like a check mark, right? It's like it touches the origin and then it bounces back up. If I tested this, -2 times 2 is, -1 times 4 is, ooh, wait a second.
It's still like proportional.
1 times 0 is 0. One, right? 2 times 0 is, Does it make a line?
No. Well,
Does it make a straight line?
no.
No. So it's not a proportional line. So can I always just use the table? Because when I look at this table, it works, right? But not necessarily when I graph it. Okay? So this is not proportional because it's not a line. Okay? Alright. What does it have to have in order to be proportional? A line and go through the origin. Beautiful. Alright. We can also use graphs to answer questions. The biggest thing with this is you have to read your axes, your labels. You can find the unit rate, and you can also predict what outcomes are going to be based off of reading the graph. But we have to remember, if unit rate and value and slope and constant and proportionality are all the same thing, which one's going to go on top? If we're talking about x's and y's.
Why? Goes on top of
You've
X.
got to remember that. Y goes on top. Rise over run. Height to base. Y to X. Every single time. Y's first, then X. Sometimes they're going to be nice to you and tell you the order. Like in this question, it says the graph shows the speed of a subway car. Find the speed in miles per minute. So they're going to tell you what they want first. They want miles first. And then they want minutes. Miles to minutes. Sometimes they're not always going to do that. Look at your graph. You've got your x-axis and your y-axis. What is your y-axis labeled? In miles. So that's your y. And your x-axis is labeled minutes. That's your x. Y to x every time. So we want to know how much it is, how many miles we can go per minute. What does that mean when I'm doing per minute?
I'm trying to figure out what's the speed of the subway car.
Alright, it's the unit rate. We want to know how many miles in how many minutes. How many minutes are they talking about here? How do we know it's 1 minute? What else tells me it's 1 minute? There's not an S. Look. Miles, minute. Plural, singular. Singular means how many? One. So I'm looking to see, I want to know how many miles I can go in 1 minute. If we're talking about miles to minutes, I could set up a ratio box if I wanted to of miles over minutes or y over x, and I can come over here to these points and use that. I've got point A, I got point B, and I got point C, okay? I use point A. Remember, your first one is your x, and your second one is your y. So I can go, my y is what in point A?
1/2.
1/4.
Oh, my Y. Oh.
Your y is 1/4. You can go 1/4 of a mile in how many minutes?
1/2.
And half a minute. Cross multiply and divide. Y equals 1/2. Or, if you look, basically in this scenario, you want your x to equal 1. Do you have a point on the graph where your x is 1?
Yes.
A, B, or C? Look at point B. Isn't x 1? What was your y? If you'll find where x is 1, then your y will be your answer. Also, wherever your x is 1, goes back to up here, wherever your x is 1, your y is the k, or the slope. Where your x is 1, the y is also the slope. It says interpret each plotted point on the graph. Then identify the unit rate and slope of the graph. We want to know what is the slope here. How do I find the slope? You can do height and base. I can go from point A to point B to make my triangle. What's the height there? 4. 1, 2, 3, 4. What's the base?
3.
But look at it. What is this skip counting by?
10.
So it's not just 4, it's
40.
something's not right. Does this point reach all the way to the 20? Where's it at? 15, right? So this is actually a distance of 45. So you have 45 over 3, which gives you 15. Or, if you notice, slope or the unit rate, wherever the 1 is, your y is going to be your slope. So where is x1? When x is 1, what is y?
15.
So your slope is right there. Or you could have just done your points of y over x. 15 over 1 gives me 15. 60 over 4 gives me 15. The easiest way is to look for where x is 1 and know what y is. So look at number 20. What are you going to look at? Where the x is 1. Where is the x1? When y is what?
5.
So we want to look at this point right here. When x is 1, y is 5. So 5 equals my slope. Alright, example 3 says the graph shows the area y in square feet that a robotic vacuum cleans in X minutes. Find the area cleaned in 10 minutes. So are we looking for an X or a Y? We're trying to find what? Find the area. Is area the X or the Y? Look at your axes. Read your axes. What does X represent? Minutes. And what does the Y represent? Square feet. Area, square feet. Which one are we looking for? We're looking for the area. So we're looking for Y when my X is what? We're doing Y over X. So we're looking for Y when your X is what? Find the area clean in 10 minutes. Can't I use any point here to figure that out? If I set it up like a ratio box, we want Y on top, X on the bottom. So here I've got X and Y. So I've got 8, got Y over X, over a half. Can't I solve for my Y now? 160. Alright, divided by a half, you're right, is 160. So it can do 160 . What if the question asked, what's the area in 15 minutes? What's the area in 15 minutes?
Then you'll have to do 160 times 15.
No, wow. If I was looking for 15, if I was looking for the area for 15, right, I would do Y over 15, and then I could still use the 8 to a half. And what do you get? Good. Okay. the graph shows the amount in gallons of the water pumped by a well. So the graph is the well. The table shows how much is pumped by a sprinkler. So this is the sprinkler. Which pumps water faster? How can we figure out faster or the best rate?
We do X
It's what the same thing over and over again. What is it? Y over X. Y over X. We're finding the unit right here. Okay, we're finding the value. Which one has the best value? Value is Y over X. So we're finding the value. Value is the same as slope. Slope is Y over X. So I can come over here to my pump, my well, and I can do Y over X. I'm going to just use my first point. Which one's Y? 9 over 1, which gives me a value of 9. If I come over here and do my sprinkler, I'm going to still do the same thing. Y over X. Y over X. So it'd be 14 over 1, which gives me 14. Which one pumps water faster? Which one? The sprinkler. The sprinkler is pumping 14 gallons in 1 minute. The well is pumping 9 gallons in 1 minute. Which one's pumping more water in the same amount of time? The sprinkler. So which one's doing it faster? The sprinkler. The graph shows average hair growth. The table shows what? What does the table show?
your friend.
Your friend. You've got to read these carefully. So this is average, this is friend. Does your friend's hair grow faster than average? So what are we going to have to find? The average or the rate in which it's growing, the unit rate, which is the same as the value. Okay, we're finding the unit rate. Which is the same as the value. Which is the same as slope. Which is Y over X. We're trying to figure out which one's faster, which one's better. We're finding the unit, we're finding the rate. So if I've got the average of Y over X of inches over years, I can pick whichever point I want to use, but I'm going to pick the first one, 6 over 1, which is just 6. And then your friend is Y over X, which is going to be what? 4.5 over 1, which equals, I'm not even on that one. So which one grows faster, the average or your friend? In the same amount of time, in 1 year, the average is 6 inches and your friend only grows 4.5. So the average is faster. Alright, this wants you to find the cost for 14 tickets. I want you to do that. Based off the graph, you find how much 14 tickets are going to cost. Alright, we've got y to x. What does your y-axis represent? Cost. Alright, and what does your x represent? Tickets. So when I make my ratio box, alright, my rate, I can pick one of the points. What point did you pick? 2/26. Okay? If this is x and this is y, y goes on top, the cost is on top, so it's $26 for 2 tickets. That's what this means. 2 tickets cost $26. 5 tickets cost $65. 9 tickets cost $117. I want to know how much does 14 tickets cost? Well, it's really y, not x. $182. Good. Alright, I want you to try this one. You're trying to decide which one is more expensive. The golden apples or the Fuji apples? Which one is more expensive? Alright, these were more expensive. If you will find the unit rate, so when it's 1, it costs $30. When I have 1, it costs $40. Which is more expensive, 30 or 40? 40. Okay.
I agree with you.
Alright, this will make a lot more sense when we get to practice it.